Hello everyone. This is Bodong Chen. I am an associate professor from the University of Minnesota. My internet is not very stable, so I'm going to stop my video from now on. And the topic of this presentation is about modeling socio-temporal dynamics of peer interaction in online discussion settings. And I'm also presenting on behalf of my colleague, Sasha Proquet, from Australia. So she's not here because of the time zone. It's like early in the morning for her, but we can save some hard questions for her when she's back online. So for this talk, I'm going to start from some research background and then talk about the research methods, introduce some findings, and discuss a few key takeaways from this study. So first of all, I think it doesn't need any explanation that online learning is such a big deal right now. And we're using online learning and blended learning in all kinds of settings, including K-12, higher education, informal setting, professional learning, and so on. While there are many different types of online learning happening, in many cases, social participation is still highlighted as a very important component of it. In particular, online discussion forums are widely used to support peer interaction and social participation in many online settings and online scenarios. And there are a lot of studies so far as well about especially how social participation is linked to all kinds of learning outcomes, and outcomes such as academic performance, 21st century skills or higher learning competency, soft skill, sense of belonging, social capital. And those studies are, again, scattered in all kinds of educational settings, from formal higher education to include teacher professional development settings. So that's all to say social participation is an important phenomenon to be studied in education, especially in online learning. And so it's not very surprising to see all kinds of efforts to boost or to facilitate social participation in online learning. And we can see there are a lot of pedagogical strategies that people are developing, such as engaging learner to read articles socially or collaboratively. There are other strategies such as incorporating questioning strategy and discussion processes. One of my favorite is developed by colleagues Alisa Weiss and Mimin Cho. They were talking about how to assign different roles to students so that when they're discussing with each other, they're taking different roles, and then that will somehow, facilitate their participation in online discussions. Besides pedagogical strategies, there are also body of work about using digital tools, using social media environment to facilitate social interaction and participation as well. And those are also, it doesn't only limit to the formal learning spaces, but also include informal spaces as well, such as, Reddit discussion board about a specific that people as a hobby sometimes. However, there are a lot of effort to promote participation. The literature is pretty clear that there's a pretty significant participation gap in many types of online learning settings. One example is what people call a rich club phenomenon that's documented in both and work that's presented here and also one of my studies. But it's basically in a lot of discussion environment, we see one group of students who are densely connected with each other. And there's other group of students, which you see the red boxes, sorry, the green boxes here. Those are not well connected with other people. And in some cases, the rich club is not letting those less connected students in, or it's hard for those less connected students to blend in, to participate and to interact with people. So a quick question for us is, why does this happen? And I'm especially thinking, why does it happen? How can we do to promote participation from everybody? And how do we make sense of the phenomena to do that? And to do that, we also face a methodological gap as well to really make sense of this phenomenon. And what I see from both my work and other studies is oftentimes we want to analyze social participation. We borrow from network analysis approaches. And oftentimes we try to rely on the static approaches that that is only looking at social relational states. That is to say, who and who is in which kind of relationship, and doesn't really take it into account those nuanced, fine-grained interactional events that's happening and that's driving the formation of relationship. Is sometimes we're taking a static snapshot of a leaf to understand how leaf grow, and that's definitely something. It's definitely a methodological gap that's kind of in between us trying to understand the phenomenon and the reality of our methodological tools. So this again is a short paper, so it's very preliminary work. But we want to make a statement that social interaction is a phenomenon that's shaped by many, many factors. So we begin by doing a review of the literature and try to recognize what are those factors that are shaping the participation of learners. So there we identify, and here we want to try to group them into this framework to guide this research. The first group of factors we recognize is about the learners themselves. It is pretty intuitive to say that learners bring their own participation goals, their own habits of online interaction, their own understanding of online learning to shape their own interaction with others. And one interesting study in the Journal of Learning Analytics is about the timing and spacing of learners' behaviors in forums, and that's one example of how their behaviors are shaping their interaction patterns. Another group of factors is more fundamentally about sociological factors that influence people interaction. And one popular example is the so-called the rich get richer phenomenon, that for people who are already receiving a lot of attention in online settings, they tend to even receive more, they tend to receive more interaction from their peers. So that's one factor. And there's another factor that's called reciprocity, is when you reply to somebody else, your expectation or what's likely to happen next is this person is going to pay back to you by replying to your interaction. So that's also a pretty well documented factor in the literature. And besides the learner individual factors and sociological factors, there are also pedagogical practices that are shaping their peer interaction. And examples such as how the activity is designed, how assessment is done, and how the instructor is present in the discussion spaces, and how the deadline are set up to shape the learner participation. Those are important factors that sometimes get neglected when we analyze learner participation. And last but not the least, technological settings and technological features are also shaping learners' interactions. And one intuitive example is if we're using Facebook and we can see that how the Facebook sorting algorithm is actually have a huge impact on which kind of information we see and who we interact with. So in our online learning setting, it's also important to consider which kind of technological affordances are benefiting which type of peer interaction. So we're trying to consider those different factors and try to find a way to holistically understand and consider them when we analyze peer interactional dynamics. So, so that's kind of the framework we're using or drawing from to help us think about this phenomenon. And the study itself was situated in 7 online courses from a large university. And those courses were about a range of different topics, including information technologies, management, innovation. And those courses share the same motivation or the same design feature, is try to promote social interaction among students. And they're also using the same platform called YellowDick to support student discussion. However, they're a bit different in terms of how they set up their deadlines, how they assess students based on their participation, and so on. But we feel they're similar enough so that we can use the data from those courses and try to model peer dynamics in those courses. And to give you a sense of how the interface looked like, to the right of this window, you see this is a screenshot of this environment. If you haven't seen this tool before, you can think of it as a Facebook group. Every class get a board, and on the board, you will see students posting their reflections or sharing news articles, and that's called a pin in this environment. And then their students can react to this post by liking it, by loving it, or marking it as not relevant. And of course, there are other students who can reply to this specific post as a way of interacting with this post. So it's pretty, again, similar to Facebook if you haven't seen this tool before. And in this data set, we had around 6,000 discussion actions that included posting, replying, liking, that type of social interaction among students. And we didn't use any content of the posts. We only used the identified time-stamped discussion action as our primary data source. So with this data set, our driving peer interaction, we did two components of analysis. The first component of the data analysis was about building temporal profiles of learner participation, because we thought it's very important to see from the beginning, to see how learners are bringing in their temporal participation preferences to begin with in this kind of online space. So what we did in this analysis was to map every activity log of every learner onto the day of the week to begin with. And then we put those information into a finite mixture models, and then try to identify different latent classes of learner based on the activity log for each course. And what we ended up was two. One class of learners were what we call time consistent posters, who tended to post consistently in a week on specific days of the week, and also who tend to distribute their participation pretty evenly across a week, compared to another cluster was tended to post very last minute right before the deadline, and who also post and disappear for a week and then come back for the next week's activities. So we kind of see consistently these two type of clusters across those courses. So with this information, we try to do the next component of analysis is a major analysis of this study, which was to build relational event models based on the activity logs, what we have from the data set. And using this novel network analysis approach called relational event modeling. And this modeling approach has a pretty significant and growing body of literature. So if you're interested in this approach, I encourage you to check those references. And here I'm going to give you a one-slide overview of this method. And REM as a method, it tried to build on the traditional social network analysis approaches. One key argument of REM is, while traditional SNA is focused on the static relationship between, for example, here I and J, REM is arguing that we need to look at the temporal unfolding of relation I and J to truly understand the mechanism that's driving the formation of this specific relational state. So it's trying to argue that we need to look at relational event in addition to relational state in any analysis of social relationship. So, and what REM does is the following. It attempts to draw from historical or the past relational event in a specific space. For example, here is the yellow discussion space. And try to use that information and combine that with actor attributes, with contextual factors such as how grouping, how students are grouped in a specific setting, or how much trust they have in the class, and so on, to collectively predict what will happen next based on the existing sequence of events. And to do that, REM is drawn from a collection of what they call sequential structural signatures to become features of their relational event models, so that by looking at the results of their model, you can tell which factors might have played a bigger or smaller role in the formation of social connections in a specific context. So that's, again, a very brief overview, and encourage you to look into the literature if you're interested. And those are, I cannot go to details of those signatures we incorporate in this model. And here I'm presenting some examples that we added to the model. And they have a bunch of different statistics you can add. Some of them are at the node level, a nodal signature. Some are at the diactic level. Some are triadic level. For example, what you see here is the familiarity factor. Our hypothesis in this study was past interaction between I and J is going to happen again. And that's pretty typical hypothesis in this setting of online discussion. And another hypothesis is past interaction is going to be reciprocated in the future. So when I reply to J, it's likely that J will reply to I in the next event or in the future. And another interesting triadic if I and J both reply to student K interact as well, this was derived based on our understanding of the technological setting, such as when you are part of a Facebook discussion, in this case, yellow dick discussion, which is similar to that, we respond to a same post, I and J are responding to the same post by K, it's likely I and J are going to interact within this thread as well. So we thought that could be a potential mechanism that drives peer interaction in this setting of yellow dick discussion. And in this table that follows the earlier sequential structure signatures, this is a collection of what we call immediate effects, which is discussed as participation shifts in the literature as well. And this is different than earlier one because they are very at the local level patterns, the turn-to-turn event level signatures. For example, AB to BA, that basically means when A respond to B, the very next event is going to be B respond to A. And another example, AB to AY, is when A respond to B, the very next event is going to be A respond to somebody else. That's what we call activity burst. So there's a collection of such signatures we added to the model to see what kind of role they play in the formation of peer interaction. And finally, we added this actor attribute. One is remember the temporal profile of time consistent versus last minute, and also the role model, or the role of being an instructor or being a student into this model as control as well. So that's how which kind of factors were added to the relational event models. Let's see what we find. And before we do that, I think it's helpful to see a little bit descriptive information of this peer interaction in those courses. And here I'm using course 1 as one example here. And to the left, what you see is a very typical, social network analysis graph, what you generate, and you see some students are having higher in degree centrality plotted in the middle because they are more attention from the peers, and some other students are in the peripheral because they didn't receive much attention from their peers. And what's under this surface is the level of activity for students are different. What you see, this is a plot of individual activity in this class. The highest number of students, the most active student generated around 100 logs versus the least active student were around 20% of the most active students. So there's a gap there in terms of how active they are. And what's also interesting is to look at the time interval between two events or two actions for every student. And what you see here is a plot, a histogram of what are those intervals, time interval between two actions for every student. And we'll see are two interesting clusters. One is many cases, those actions are tended to happen within a few minutes. Like you do this action and the next action for this person is going to be around 5 minutes later. And also there's a huge spike if you do this right now and then likely you're going to, the next action is 1 week later, which is also interesting in terms of, temporal patterns of participation. So in terms of the main body of findings from relational event models, and you will see here is a very busy table, which I will unpack in the next few slides. And here you see we build a bunch of models for every course, and we're using the two measures, AIC and BIC, to criteria of how the models are doing. The lower number it is, the better the model is. So it's consistent across its courses that the full models are better than the null models. And we have, as you might remember, different collection of sequential structural signatures that we added to the model. And those are presented in this table. And so again, it's pretty busy. So I'm going to use the next few slides to summarize these results. So first of all, the first collection of factors are about nodes attribute or actor attributes. And what we saw from the results across different courses were those students or those actors who are time consistent were connected to positive tendency of replying to others. And also those instructors are mostly positively tended to reply to others as well. However, they didn't really tend to receive other replies. The results were either mixed across courses or negative in some courses. In this study, we saw pretty consistently across courses that the actors' total degree, which is how connected they are, were connected to the receiving more replies. And also the past action of A to B are connected to getting more the same type of ties or the reciprocated tie to happen in the future. However, the triadic closure we hypothesized that didn't really have a high effect size in the studies. And continue on in terms of the immediate effects, which are about return patterns that happen in this course or in courses, we saw that the strong positive tendency for many students to kind of have this kind of activity burst. So when they come to this discussion environment, they tended to reply to a bunch of other people. And the second very strong tendency is when A send a tie to B, send an interaction to B, there's a popular, B is a popular person because there's another student also replying to B as well. So that's also interesting to recognize in those findings. So again, I'm going to skip through some findings, and because of the time, I'm going to talk about a few key takeaways from the study. So the most important takeaways from the studies are the following. First of all, the peer interaction, as we see from the findings of the relational event model, is peer interaction is shaped by a range of factors. And finding from those models show that being temporal consistent was associated with replying more to others. A learner tended to repeat earlier ties and reciprocate early ties. The immediate effects show that learner tended to reply to a bunch of peers at a time, and popular learners may attract multiple learners to apply them in a row. So those findings are all to say, the analysis of social interaction can benefit from focusing on relational events as well, besides relational state. And those social and temporal dynamics, they're hard to decouple. They're deeply intertwined in this setting, and we need to look at them holistically, and it's hard to separate them in many settings. However, this study is, again, preliminary. We recognize there's some limitation, especially we're not using the content at all in this modeling, which is both encouraging, but also a limitation for the study. If you were to incorporate more of the content to be added to the model, maybe combine the REM with discourse analysis to make this model stronger and richer. I think it's also interesting to develop and contrast pedagogical strategies in the future to see which kind of pedagogical strategy can be developed based on these insights. And finally, I think what's very interesting is how can we derive novel indices based on those sequential structure or sequential signatures for interesting analytics tool can be added to discussion dashboards if that's possible. So with that, I want to thank you for your attention, and I'm happy to answer any question you have. Thanks a lot.